All right, 1.4 notes. Creating and naming an angle. All right, so how do you make an angle? That's a good question. I'm glad you guys asked that question. Here's how you make an angle. You start with a point. Don't call it a dot. It's called a point. Repeat after me. It's called a point, not a dot. Thank you for repeating after me. Then you draw one of these things. It's like a line going in one direction, but it's not called a line. It is called a ray. So whenever you have a point, not a dot, and then it goes in one direction, this is what is referred to as a ray. Now, to create an angle, you go back to the point, and from that very same point, you create another ray, like that. And voila, you have just created an angle, okay? So what is an angle? How do you create an angle? Let's give it a couple of points here, a couple bullet points. So first of all, it is made up of two rays. And there's the first bullet point right there. The second bullet point is that it has two sides. So an angle is not a shape per se, but it does have two sides, okay? And the third thing that we have is that it has one corner known as the vertex. Okay, so whenever we have an angle, we're going to make up an angle by drawing two rays. The two rays have to start from the same point. That means it's going to have an angle, always has two sides to it, and it has one corner, and the corner is what is known as the vertex. Okay, so that's how we create an angle. Now let's go over how do you name an angle. All right, so the next thing that we're going to talk about is how to name an angle. So let's go ahead, name an angle. So let's take this angle that we just created. And once again, how do you create an angle? You start with a point, not a dot. You draw a ray, which is kind of like a line going in one direction. You draw another ray from the same point right there. So you have two rays. They both start at the same point. That point is the corner. It's going to be the corner of the angle, and that corner is known as an angle. Now, at that point, I'm going to put a letter, and I'm going to put the letter F. And along the ray going kind of like angling up toward the top of my paper or my picture here, I'm going to put another point there, and I'm going to call that point N. And down at the other ray somewhere, doesn't matter where, I'm going to put a point, and I'm going to call that L. All right, so when you name an angle, you always use three letters or you use one letter. Okay, very important that you remember that. So when you name an angle, use three or one letter or letters to name an angle. Okay, you never use two letters to name an angle. You never use four letters to name an angle. You're always going to use three letters to name an angle, or you're always going to use one letter to name an angle. Okay, and the way that you would name this particular angle is this. If you're going to only use one letter, you always use the letter that's at the corner of the angle, that's at the vertex of the angle, which would be F. So the way that you would name this is you would put this little symbol right here. That symbol that I just drew, that is the symbol for the word angle. So I'm going to put it up here, that symbol right there. That symbol is the word, that means the word angle, A-N-G-L-E. And then you would put the letter F next to it. It would be perfectly legal, okay, acceptable to refer to this angle as angle F. Another way that you could name this angle would be using three letters. And when you use 3 letters to name the angle, you could call it angle NFL. That would be okay. Or you could name this angle as angle LFN. Notice that when you use 3 letters to name an angle, the middle letter is the letter that is at the corner, which is known as the vertex of the angle. Okay, so naming an angle, if you're going to use 1 letter, you always use the letter that's at the vertex. If you're going to use 3 letters, the middle letter has to be the letter that is at the vertex. Okay, now, next thing is, how do we represent an angle? So you're going to see a lot of diagrams. You're going to see a lot of pictures today, tomorrow, in the future. And then how do you represent an angle? How is an angle represented when you see it in a picture? There's usually 2 ways that you see an angle represented. I'm going to draw 2 examples here. Notice how I created that angle. I drew 2 rays. Both of the rays started at the same point. I'm going to draw another angle over here, just like I kind of did the first one. There's a ray. There's a second ray. The way that you represent an angle is that on the inside of the angle, right next to the corner or the vertex of the angle, you can see an angle represented with a letter, like the letter A. You could use any letter you want, A, B, C, D, E, F, G, X, Y, Z, whatever. Okay, this angle is represented as having A degrees. Or you might see an angle represented by an algebraic expression like maybe 5x minus 1 degrees. Okay, so when we represent an angle, we're always going to put that representation of the angle inside the angle, right next to the corner, the vertex, and we're going to represent it with a variable or like an expression that's a variable. Okay, and so today what we're going to be talking about is we're going to go over 1, 2, 3, 4, the 4 most popular angle relationships that you tend to see when you study angles. Okay, so today we are going over a concept called angle relationships. Now, what does that mean? This means to have a relationship, you have to have 2 or more items involved. So we are talking about 2 or more angles. Okay, so everything we talk about today, there's actually going to be 2 or more angles, and they're going to be in a special type of relationship. The first one is what is known as vertical angles. Okay, so notice what I am drawing. I just drew a line, and I'm going to draw a second line that intersects the first line. There we go. Now, in the middle part of where the 2 lines intersected, where the 2 lines cross, I just created 4 angles, okay? The angles across from each other are vertical angles here. So I'm going to outline the 2 of the vertical angles in red. The angle right here that I am outlining in red, made up of those 2 rays, and the angle that I'm going to outline in light blue, made up of these 2 rays here. Those 2 angles are the vertical angles. So the angle where I just wrote the 5x, where I'm representing the red angle as 5x minus 8 degrees, is a vertical angle with the angle that I'm representing with the blue as 3x plus 12 degrees. Okay, and here is the relationship that is true about vertical angles. The relationship. Vertical angles are equal, period. So whenever you see a relationship of two angles that would be classified as being vertical angles, the relationship of those two angles are that the vertical angles are equal. Okay, and what this does is this leads us to an example. And the example is that I'm going to use, because the vertical angles are equal, that means the angle represented with the 5x minus 8 degrees is equal to the angle that it's vertical with, which is represented with the 3x plus 12 degrees. So an example of applying vertical angles to create an algebra problem such as 5x minus 8 equals 3x plus 12, that would be an example of applying the relationship of vertical angles. Now what we're going to do is we're going to solve this equation and find the answer for x. I'm going to add 8 to both sides of the equation. That would now create a new equation after the 8's cancel out, which would be 5x is equal to 3x plus 20. My next step in solving this equation for x is I would minus 3x from both sides of the equation. That would create a new equation, which would be 2x is equal to, and the 3x's would cancel out, 20. And then I would divide both sides of the equation with 2. And that means my answer for x would be x is equal to 10. X is equal to 10. Okay, so there is an example of where I'm applying the relationship of vertical angles, and I am using that relationship to solve, to set up an equation, and then solve for an unknown variable like x in this case. Okay, next pair of angle relationships is one which we call a linear pair of angle relationships. Here's how you make a linear pair of angle relationships. You're going to start with the point. You're going to have a ray. And then you're going to have another ray starting from the same point, but the two rays are going to go in opposite directions. What did this just create? That created a line. Notice in the word linear, there's the word line. And then I'm going to go back to the point right here, and I'm going to draw another ray. So what we have in this problem is we have two angles. One of them I'm outlining in red. That one right there that I just outlined in red. And the other angle that I'm outlining in blue. And notice that when I outline it in blue, there's a side that is both red and blue. Okay, it shares a side. So the red angle shares one of the two sides with the blue angle. Okay, whenever you have a linear pair of angles, you always notice you will have a shared side there. And so these two angles are side by side because they have a shared side. And not only are they side by side, but they are side by side on a straight line. Okay, and so let's say I represent, okay, so first of all, let's go to the relationship. So the relationship of linear pair of angles, this is the relationship that we have for a linear pair of angles. They are two angles that are side by side on a line. Two angles that are side by side on a line. Linear pair angles add together to equal 180 degrees. So a linear pair of angles are always going to be two angles that are side by side on a line. And when angles are linear pair of angles, the relationship that they have is that they add together to equal 180 degrees. Okay? So let's represent the angle in red with 6x plus 8 degrees. Let's represent the angle in blue, that is a linear pair with the angle in red, with the expression 4x plus 12 degrees. And so the equation that you would create in order to use an example of linear pair of angles would be the 6x plus 8 angle degrees plus the 4x plus 12 angle, which is the blue one, represented with what I used with blue. The relationship is they add together to equal 180 degrees. So an example that we would use this relationship to create an equation would be 6x plus 8 plus 4x plus 12 equals 180 degrees. And then I would use algebra to solve this. I would combine the 6x and the 4x, and that would make 10x. I would combine the plus 8 and the plus 12. That would make plus 20. So now I would have the equation 10x plus 20 equals 180. Continuing to solve, I would now minus 20 from both sides of the equation. After the 20s cancel out, I would have the equation 10x is equal to 160. And then my last step would be to divide both sides of the equation with 10. So that would give me an answer of x is equal to 16. So using the relationship of linear pair, which means that together they add up to 180 degrees, I create an equation and I solve this particular equation and I get x is equal to 16. Okay. The third out of 4 angle relationships is alternate interior angles. Just says alternate interior here, but if you want to add in angles, this will be 2 angles as well. And here's how you create alternate interior angles. You're going to have a line, and then you're going to have another line that's parallel. So you're going to have 2 parallel lines. And then you're going to have a third line that goes through, intersects the 2 parallel lines. So to have alternate interior angles, you're going to have 2 parallel lines. Yeah, type that in here. You're going to have 2 parallel lines intersected by a third line. So there's the first thing. That's how we get alternate interior angles. Now, where are alternate interior angles? Alternate interior angles are, and if you notice, there are 8 angles in this picture. I'm going to number off all 8 of the angles. 1, 2, 3, 4, 5, 6, 7, and 8. Alternate interior angles, the example of them would be angle 3, which I'm outlining in orange, and angle 6, which I'm outlining in red. So alternate interior angles, if you notice, they share a side, and they're both of the angles are on the inside of the parallel lines, okay? But they're on alternate sides of that third line, okay? So they are 2 parallel lines intersected by a third line. The angles are both inside the parallel lines, but on alternate sides of the third line. Okay? And here's the relationship of alternate interior angles. Alternate interior angles are equal. So just like vertical angles, alternate interior angles are always equal to each other. So what does that mean? It means that in this picture, the orange angle, which is represented with angle 3, is equal to the red angle, which is represented with the angle 6. So angle 3 is equal to angle 6. And if you're really good at recognizing alternate interior angles, you will also notice that angle 4 is equal to, because it is an alternate interior angle with which angle? What angle is angle 4 an alternate interior angle with? If in your mind is screaming angle 5, you are right on board. So that means whatever angle 3 equals, it's going to be equal to angle 6. And whatever angle 4 is, it's going to be equal to angle 5. Okay? Hopefully this is making sense to you guys. The last one, the last relationship, the triangle angle sum relationship. So in order to have this relationship, well, you have to have a triangle. So let's just draw the standard old triangle right here. And a triangle, that word literally means 3 angles. So let's represent each one of the 3 angles. That's a great idea. Let's represent the bottom left angle with the expression 6x plus 4 degrees. Blow it up for you a little bit so you can see it. Let's represent the angle at the top with the expression 3x plus 1 degrees. And let's represent the angle at the bottom right with the expression x plus 15 degrees. This is probably a relationship about the angles of a triangle that you already know. But what is the relationship? What is the triangle angle sum relationship? The 3 angles inside a triangle, inside any triangle. So this works for all triangles. Adds together to equal 180 degrees. So the 3 angles inside any triangle adds together to equal 180 degrees. Okay? So how do we use that as an example, and how do we create an equation that we could use? So let's go to our picture here. So what this relationship tells us is that the expression 6x plus 4 degrees, when I add it to the top angle, which is represented with 3x plus 1 degrees, and when I add those 2 angles to the third angle, which is represented by the expression x plus 15 degrees, the relationship is that those 3 angles are going to add together to equal 180 degrees. So the triangle angles have the exact same relationship as the linear pair of angles. They add together to equal 180 degrees. It's pretty awesome. That's the same relationship, even though it's 2 totally different things. Okay, and then I would use this equation, and I could use it to figure out or solve for the value of x. I'm going to combine the 6x, here's how I solve it, with the 3x, with the x. So I'm going to combine like terms. 6x plus 3x plus x is 10x. So this is going to give me a 10x. Then the next thing that I'm going to do is I'm going to combine the positive 4 with the positive 1, that's 5, with the positive 15, that's 20. So when I combine like terms, I get a much simpler looking equation of 10x plus 20 is equal to 180. And then I solve this equation out in 2 steps. Step number 1 is minus 20 from both sides of the equation. After the 20s cancel out, my new equation would be 10x is equal to 160. And then my last step in solving this equation is I would divide both sides of the equation with 10. And after the 10s cancel out, I get x is equal to 16. Okay? So these are the relationships that you're going to be looking at in your homework tonight, in your assignment, and then you're going to be using the relationships that they have to create equations. You're always going to be looking for the triangle angle sum, or alternate interior angles, or linear pair of angles, or vertical angles. There's the notes on 1.4.